Hello. Hi guys, good morning. Welcome back to a new video. In this, we will see two problems, or basically, we will see just one problem, but we will see from scratch to the most optimal solution. So this is just the improvised. So find the number of ways to place people one, and find the number of ways to place people two. So people 2 is the improvised version. The only difference is the constraints. You can see in people 1 the constraints of n and the points are very small, while in people 2 the constraints are large. So we can just consider that okay, we will just study the problem number 2 and then we'll go on from the very brute force. Again, we'll see the code also for that, and then we'll go to the most optimal solution for that. Cool. Let's quickly see what the problem says. It's a big question, big problem, but no worries, that will be very short and concise. I'll tell you the most important points in the problem. So problem says that we are given a 2D array of points. Now points is nothing but n cross 2 simple matrix, which means okay, I have n points and each point I represent by x and y coordinate. So I can have 0, 1, 1, 2. So basically this is one point, this is next point, and each point is represented by two coordinates x and y. Great. And this is same thing. Okay, points of I is xi comma yi. Now we define something no worries on that part. Now we have to place n people including these two person, Kisato, Shisato or Takina. Let's name as C and T. So we have to place a person C and place a person T at these points such that there is exactly one person at every point. Again, these persons I have to place such that there is exactly one person at every point. Okay, and C wants to be alone with T. C wants to be alone with T. What he mean by being alone is that C will build a rectangular fence with C's position as the upper left corner and T's positions as the lower right corner of the fence. And again, they just have some few notes. If any person other than C and T is either inside or on the fence, then C will be sad. So you specifically want that C should not be sad. So basically he's saying that C's position as the upper left corner. So upper left corner, if you imagine this as a box, so in this box C position will be upper left corner and T's position will be the lower right corner, and thus C will try. Imagine C as a boyfriend and T as a girlfriend, so they want to be alone and they will form a box, and when they form a box, they want that any other point should lie outside. So they should not lie on the fence which they have made or inside their box. It should not be. They should be alone in this area and also on this fence also. This is what the problem is saying. Let's see the last line. Return the number of pairs of points. So you saw we have n points. Out of those n points, I have to return the number of pairs of those points that I can make for C and T such that C is not sad, which means such that I have to find the pair of points C and T such that all the other points are actually outside, not lying inside my specific this portion which C and T have made. Okay, great, seems fine. Now we have few points and they just said that okay, for sure C should, again remember, C should be on upper left corner and T should be on lower right corner. So they have given a few examples where it is not valid. For example, let's say you have something like this, right? Okay, if your C is here and T is here, you remember T should be here, not here. So this is not valid. Again, other condition is, what if your C is at 1, 3, C is here. Again, remember C is here and T is here. Remember, C is here and T is here. So he's saying okay, C is here and T is here. This is not valid. So C position at 3, 3, C position at 3, 3, and T's position at 1, 1. This is not valid because T should be after my C. And again, with the C as 1, 3, okay, and T as 1, 1, and it is Takina's position is not the lower right corner of the fence. So you can see the fence will not be like this. The entire thing will not be like this because the position of T is not the lower right corner of that specific fence. no worries, we'll see the example itself more that what actually they want. So now we know one thing, that C can be here and T can be here. But there's one thing also you will see in the example, that if your C is here and T is here, that's also valid. It can be also in line. If your C is here, T is here, that's also valid. But Aryan, above you saw, oh yeah, for sure, box cannot be made, that is for sure. So this point will never come in picture. We can have a line, we can still have a line. So you can also see that we can still have a line. For they will also mention for some line and stuff, but yeah, we can still have one line. So that's also possible for this C and for this T. It is also possible. It's just that answer is 2, which means this case and this case, it is not this answer, because in this box which they have made, in that perimeter, other point is coming in. Other point is coming in. That's the reason this is specifically not the example. Okay, no worries. For this specific example, again remember, C should be here, T should be here. Yeah, that's a valid example. That's a valid use case, and it's true. C is here, T is here. That's also true. C is here, T is here. It could have been true, but other point is coming in between. Like again, any point comes inside or on the perimeter, I am screwed up. C and T are screwed up. So the answer is 2 for him also. Again, for this you saw that I should have a C and then a T on the right side or on the down. I could have, okay, if I have a C here, let's imagine this as a C. So you could have a T in the line of it, or on the down of it, or on the right of it. And you can see no T I have. Okay, for this specific C also, I have no T in this entire range. I have no T in this entire range. Okay, and for the C also, I have no T in the entire range. So for sure, none of them, C and T, can never form a pair. So answer is 0. So one thing you have seen so far is that, for sure, one thing that as you saw in this example, I can try for all possible pairs. I have n points, and 1 point I'll assign to my C, other point I'll assign to my T. If I assign 1 point to my C, other point to my T, again that point T can be this point also, any point can be my T. So if this point is my C, any other point can be any point whatsoever. If I assign this points pair, I just have to verify that will they form a good pair or not. So okay, n square such pairs I can form. So one thing is, okay, I will form n square pairs. Now to check that specific pair of C and T, if that is good or not, I will have to check that all the other points, firstly C should be on the lower upper left and T should be on the lower right. This is the first condition which it should be there. We will see how to do in code, but yeah, this is this is the first condition, that you can have your C on the upper left and T on the lower right. Now when this is the case, okay, when this is there, just make sure that all the other points apart from C and T should not be lying inside or on the perimeter of my C and T. So how to do it? As simple as that. Let's imagine you have this point as CX CY. Again, C, the coordinates of C. Again, I'll go on to all of my pairs. I have n square pairs, and to check for one pair of C and T if it is actually valid or not, I will have to go and iterate and check all the other points, that if they are lying inside my box made by C and T or not. So it is nothing but O of n square into n. N square is the number of pairs, and n will be my simply checking if all the other points are actually lying inside my box made by C and T pair or not. Right? So n cube, you might say, okay, Aryan, this is an n cube algorithm. We'll see that how to solve this n cube also. But if it's an n cube algorithm, so because of the first problem, this n cube can for sure work, but because of the second hard problem, n cube would not work. So n cube would not work for this specific case, but still we will see that how the code of n cube will look like. For before that, to have a quick glance of how we'll solve it. So we will have 1 point. Again, we will try for all possible n square pairs. Remember, mark my words, I'll try for all possible n square pairs. I'm not saying if I have my I here, which means if I have my C here, so I'll just try for T and T like this. Nah, if I have my C here itself, I will try my T here also, I'll try my T here also, I'll try my T this also, but C and T can never be same. So for sure I'll just mark okay if C is not equal to T. But remember, for one C, I'll try for all possible C's, which means for I equal to 0 to I is less than N, which means for C, let's say J, which means for T, I will again go from I equal to 0 to I is less than N. I'll not say I plus 1 for J, because you can see if this is a C, my T is 6,2. So it is possible. It is possible. Yeah, it is possible. Great. So have a quick glance at how we'll solve the C and T thing. Okay, let's imagine that I will take one pair, C and T. Now, I have to just make sure that any other point, let's say, again, I will have to check for all the other points, which means all the other points. I will again have another for loop, which will try for all the other points and will check if that point, let's name that point as kx comma ky. That point kx comma ky should not, again the point kx comma ky is all the other points apart from C and T. They should not lie inside or on the perimeter. How to verify that? Simply make sure that your x, again, just bifurcate in these kind of conditions, bifurcate your x and y. Make sure if your x is between your cx and tx, which means it is in the bounds. So if your kx is between cx and tx, then your x is inside this range. X is in this range, which means x is in this range, x is your kx is in this range. But okay, but outside also, if your kx comma ky would have been outside, then it would have not mattered, right? Because you only are concerned when it is inside the box or on the perimeter of the box. So one thing is also only considering kx, it is between my cx and tx. That's not sufficient. You also have to make sure that your ky is also between your ty and cy. This also should be there. When this is there, which means it is inside this range. So okay, it is inside this range and also inside this range. When and comes in, which means intersection comes in, so it is in this range of my box itself. If this is the case, for sure this C and T pair is not valid, because some K point is coming inside this specific box. Okay, now this is to check, okay, if that C and T pair is valid or not. But also make sure that your C, which means it just makes sure your C and T pairs are valid, as in any other point K is not coming inside or on the perimeter of this box. But also make sure that your C is always on the upper left corner and T is on the lower right corner, which means if this is your cxcy, if this is your txty, then your cx should be less than equal to your tx, which means it is in the left of your tx, and your ty should be less than or equal to your cy. If this is the case, only then I can actually imagine that I will have my C on the left, and also again this represents my C's on the left and this represents my C's above of T. So it will be left above, which means upper left, and this same represents if something is upper left to me, which means I am to the lower right of him. So this will make sure that my C and T are valid. This condition will make sure that my any other point, if it is lying inside, then this C and T pair is not valid. Cool. Let's quickly see the code. It's pretty simple, exactly same as what we saw. We will just try, okay, both my C and T pair, and then for the C and T pair, I'll just try for all the other points as K, and then check if that point is lying inside, it's not valid. If not, then okay, it's a valid pair of C and T. So I'll just simply take my I, this is for my point C. Now I just took a CX and CY. Right, then I will try for all the possible J's, which means all the possible T's. Okay, I will have a TX and TY. Now just have a quick check if your I and J are equal. Oh, continue, because I and J should not be equal, because you are seeing you are trying for starting from 0, so I and J can be equal, but I and J should not be equal, so continue that. Now the main condition is if your TY, again remember it was a CX CY, it was a TX TY. Remember, Ty was always less than or equal to my Cy. If Ty becomes more than my Cy, again remember your Ty in the picture also you can see your Ty is less than or equal to your Cy. So if this condition is not satisfied, which means if Ty becomes more than my Cy, more than your Cy, bro. It's not a good pair, bro. Move on. Or as you can also see that your cx is less than equal to your tx. So if your tx becomes, sorry, if your cx becomes more than your tx, then also it is not valid. So also in that case, bro, move on. I know it is hard to move on for you, but still you have to learn to move on, which means continue. Now coming on back, we will have a flag as true by default, which means saying I'll try for all the other points rather than C and T and check if they are lying in the perimeter or on the inside my box of C and T. So by default, I assume that it is possible. If not, then I'll mark this flag as false. Now, when I'm saying I will try for all the other points, make sure that you discard C and T points. So I discard my point C, I discard my point T. Now, when these points are discarded, I'll try for all the other points, which is K. Right now, this represents my Kx. Right, this represents my Kx, this represents my Ky, this represents my Ky. As you have remembered that for that, if I just go back and show you the condition that a point, if my Kx is more than equal to my Cx and my Kx is less than equal to my Tx, I'll just mark this again, remember this, snapshot this, and I'll see the same thing exactly in the code. Right, if my Kx is more than equal to my Cx, right? This condition is done, and my Kx is less than equal to my Tx. Okay, which means if I come back, which means it is in this range. It is in this range. But it is not required. Like, it is not important that it is coming in the box. It should also be in this range. Which means I'll also check if my Ky is more than equal to my Ty and my Ky is less than equal to my Cy. Okay, come back that my Ky is more than equal to my Ty and my Ky is less than equal to my Cy. If this is the case, which means this point Kx comma Ky is lying inside my box made by Cx and Cy. Sorry, a box made by my C and T. If it is the case, mark the flag as false. It is not a good pair. C and T is not a good pair. So I'll simply say it's a false. But if it is a true, which means this C and T pair is awesome, then mark the flag as, like, your flag will be true. So you will increment the answer, which means you have found one good pair, and thus your answer you can simply return, which is the count. Thus you saw that you have simply go on and tried for both the possible pairs. Okay, it's an O of n square pairs, and for every pair you are going to all the possible case, which means all the other pairs, all the other points, and then checking. So it's again O of n. So in total the time will be O of n cube. Space, as you can see, you are not using any extra space whatsoever, so for sure space is O of 1. Okay, that seems good, but it will not work for the hard problem. So what is the optimization which we can have? Okay, one thing which we can think of is while we were building the specific answer and we had all these points with us, let's erase everything, right? Let's erase everything. Now one thing I know, I have to reduce something. Now what to reduce? The point is what to reduce. So I will again have to go on to all the possible pairs. That's one thing. But can I if we go on back and look at the specific code, what can I reduce in the specific code? I know, okay, I cannot do O of n cube, but I know my n is 1000, so I can do O of n square. O of n square will still work, which means I can still try for all the possible pairs. But I can try for all the possible pairs, that is true, but to know a pair is good or not, I was using the specific loop. That is one thing. I will have to try for all the possible pairs, and I can do that also. I know that. Okay, I can do that. Okay, because I know I can do n square. I can try for all the possible pairs. But to know a pair is good or not, that was taking time for me. So rather, I will go on to only those pairs which are good for me, which means I will have to figure out what pair is good in the shortest possible time. And that shortest possible time is O of 1. How we will do that? As simple as that. Firstly, to know if a pair of C and T is valid or not, we had seen two things. One thing is that for T, C should be on left and upper left corner of my T. I know for T, my C should be on left and up. That is one condition which I have to check, and I know that, okay, I can check that in O of 1 time for sure. right? Okay, but the other condition was that if they C and T, if they will make a square, so any other point should not come between them. That was one thing. So what I can look off from here, if I have a point C and I will just try randomly any points. So if I have my point C and my point D, I know I will try for the sequential points, which means for this C, what all T's can form a pair, which means this T1 can form a pair, this T2 can form a pair, this T3 can form a pair, because you can see if I just put a T3 here, so you can see this can simply form a box, okay, this can also form a box, okay, this can also form a box, okay, but let's say if I have a T4, this cannot form a box because other points are also coming. So I'm just trying for all the possible T values. For one C value, which means let's say C1, I'll try for all the other pairs, because I know I can do n square, which means for one I can try for all the other values, and for let's say other time I will just put this as a C2 and then I'll just try for all the other values. Similarly, I can try for all the possible pairs. That was one luxury which was given to me. But coming on back, that still my aim was, while I am checking for the pair, I should figure out if that pair is good or not. So one thing obviously, which while I was making this random picture, I could see that one thing which I should satisfy is, for a specific C, my all T's should be after him, because you remembered, right? Your all T's should be after him, and it can be also equal to him, but all T should be equal after to him. So I know one thing, that if this is a CX, this is a CY, this is a TX, this is a TY, then my CX should be less than equal to my TX, and my CY and my TY should be less than equal to my CY. So one thing I will make sure that to not go on, like one thing was okay for this specific point, I'll go on to all the points which are after him. Now to go on, I will make sure that all the points after him, after me, all the points after me should be having my TX, which means should be having my X coordinate more than me, right? Okay, but Aryan, what about the X coordinate having same, which means if some coordinate T is just below you, or like maybe if the X coordinate is same, that it can be above you also, then what? Okay, then if the X coordinate is same, one thing I've made sure is that I will align all my points such that, again, why I am doing this kind of thing, it is because I want for a C, all my T's which are valid are after me. So I will not have to go back and forth. I'll not have to go backwards again to all the points. I'll only go afterwards. Now for this afterwards point, I know, okay, I will just simply sort all the points in the decreasing order of their X coordinate. So X coordinate having less will be here, which means C1 will be here, next point will be here, let's say T4 is here, so next point will be here, and next point will be here. So one point, next point, next point, next point, and you can see it is going in. Okay, let's imagine this as the whole coordinate system. So your first point is least distance from X, next is okay distance, next is least distance, and next is other distance. So this is how you can just go and plot your points, okay, on the basis of the X coordinate. But comes the fact, what if your Y coordinates are, what if your Y coordinates, what if your X coordinates are same, which means for two points, if your X coordinate is same, then which point you will put first? You will have to define the simple sorting, right? What if the X coordinate is same? By default, if you go by the default sorting, then what he will do is he will say, okay, whosoever, again, by default sorting is if you are sorting in the ascending order of X, and the same way it will sort the Y also in the ascending order. So what will happen is your T1 point will come first and next point will come as T2. Okay, Aryan, that seems okay, that's completely fine. Okay, so I can just simply do like this also. But if you do like this, which means sorry, it will be a T2, it will be a T1. Having a lower Y coordinate will come first, and then having a higher Y coordinate will come next, if I sort by default logic. Now, is it having an issue? Maybe not. Because why? Because if I am at this point C, which means just imagine this is a number line I and J, you are at this point I, You will try on for all the possible j's after I, because you have now sorted it. The only luxury you wanted for sorting is so that you can actually go in afterwards. Now you will try for all the possible j's. Okay, j, but the first j which you will encounter after this I is will be this point t1, because for sure in the sorted order this will be the first point, because x coordinate is minimum but the y is also minimum, so this will be the first coordinate j which you will encounter. So can you say will this form a good box? You cannot. Because why? Because you needed the help of next point which was t2, because he was above him, and while making the box he is coming in picture, which means anything which is above me is impacting me. So rather what I can do is I can actually sort the y coordinate in the descending order, which means whosoever, okay, if the x coordinate is same, then whosoever has a higher y coordinate, I should encounter them first. It will help me. How? Okay, how it will help me? That, okay, if this was my I coordinate, then the first coordinate which I will actually try and check the pair I will form is this specific C and T. And for sure it's a first pair, so it will for sure work. Okay, for sure work. Next time, I know one thing, that my height itself is this bar. It is this bar. Now next time I am trying for a lower height, I know for sure I will encounter something because of this. So if I'm trying for a lower height, okay, you will see lower height, then this will come in picture. Now Aryan, okay, that makes sense, okay, lower height, but what about the other coordinates? What if my next coordinate, which is t3, is here? Again, it is in the lower bar. My height, okay, this t1 has set a benchmark. This is a benchmark. Anything which will go below me, which means any height which will go below me for sure will actually encounter me. So any height which is going below him, which is going below or equal to my t1, we actually start encountering t1 in between or on the border. Let's say if it was below, then you saw it encountered inside it. What if it would have been like just at the same level? Still, it would have been at the border. So my t1, it's set a benchmark that, okay, anything now will actually be more the height. Okay, now other point, the next point which came in, again remember the points I am going on in the sorting order of their x coordinate, because I have sorted on the basis of x coordinate, but then I realized I cannot sort on the basis of y coordinate, because I would actually go and have to go backwards again and again. So I thought, okay, let's, for the same x coordinate, that let's sort on the in the descending order of the y coordinate. So now when this point is done, I have, and this every point you encounter as a t point will set a benchmark for the other points to come in future. So now you will see that this t3 is actually more than my benchmark. Oh, now he can come. As you can see, now he can come. But what if next time I have, let's say, t4? Now this t3 has set a benchmark which is higher than t1. So now my t3 is a new benchmark for me. So anything which is equal or below t3 will not form a pair. And as you can see, if I try to form my pair with my t4, it will not form, because my t3 will come in picture in between, which I don't want. So what I can do is I can try for next coordinate having height more than my t3, so that my t3 will never come in picture. And that is how you will actually be sorting your points in the, firstly on the basis of their x coordinate in the ascending order, but if the x coordinate is same, then sort on the basis of their y coordinate in the descending order. So how it will look like is, it will look something like this. If you had these 5 random points, then you will firstly sort on the basis of their x coordinate. So you will see first, then both are the candidate for second and third, and then it is fourth, and then it is fifth, on the basis of the x coordinate distance from the x axis, right, from the y axis, right? So it is a x distance. But still, here I had a dilemma that who to pick up. So I recognized whosoever is higher in the y coordinate will actually be encountered first. So I should encounter him first. So I thought, okay, whosoever is having x coordinates as same, in that cases I will sort them on the descending order, which means having more y coordinate will come as a first point. So you can see it is a second point, it is a third point. Now I have named all the points in the ascent, in the actually sorted order. Now my sorting, like sorting, because of my sorting, it looked like 1, 2, 3, 4 and 5. These are my 5 points. Now I'll simply apply and try for all the possible pairs. Okay, I'll imagine this as my Cx, Cy. And then I'll go on to all the other points after me, because I know after me are all the points having x coordinates more than or equal to me. So first candidate is 2. For sure, it is the first candidate's benchmark right now. Let's imagine the benchmark k as this benchmark. Right. Let's imagine the benchmark is 2. So right now the benchmark, which means the height, let's say the height right now is 100. Its height, which means its y coordinate. Its y coordinate, it's ty. So let's name it as t2. So benchmark right now for k is t2. K is saying, okay, it is a benchmark height. It is a t2. Anything which goes below my t2 will for sure start encountering my t2 in picture, in between or on the border. So this is my benchmark. Anything I want to form a good pair, any coordinate t should actually be more than my this benchmark height, which I have start putting in. So right now, no benchmark height was there. By default, the initial benchmark height was -infinity, no benchmark height. When he came in picture, he will check, okay, my height is ty. It is for sure more than the benchmark height, so I can for sure make a good pair. So 1 and 2 will form a good pair. Great. So right now, I'll update my benchmark height with ty. Now, I'll encounter the next point. Again, I'll go on sequentially. I'll encounter the next point, which is t3. So this is the next coordinate. This is the next valid candidate for my t coordinate. Now he will say, okay, my height is it's a t2. Remember, it is a benchmark height for t2. Or you can say also t2y. ty2. That okay, it's a y coordinate for my point 2. Now you can see my ty3, which means my ty3 it is less than my ty2. So for sure he is not a valid candidate for my t, because as soon as you will start encountering him, he will have your 2 on the border. So okay, it's not a valid candidate. Okay, simply go on to the next coordinate, which is 4. Now one thing is for sure, although your ty4 is actually more than your k, but bro, one thing, it is actually also more than your cy, which is not valid. If you remembered, if it is not valid, you should have a c and t as this pattern. T can be here, but it can never go up. It can lie in this range. Your t can lie in this range. It can never go up. So okay, I will have to just have a one if condition, that if my ty of this coordinate, if it is more than my cy, bro, continue, go on, it will not have an impact. Now comes the next coordinate, which is this ty5. His y coordinate is more than my k. K was a benchmark height. So this is more than my k. For sure, this can actually form my answer. And you can see it can form your answer with not encountering the previous, because previous has a lesser height. So it will not impact your current pair which you will be forming. And that's how you can form these 2 pairs. So you saw, for every point C, firstly, you will take a sorting, which is n log n, and then you will just try for this specific point. I tried for all the points after him, and the same way I'll do it for the next point. Okay, now the next point will be this cx comma cy, and then I'll try for all the points after him, which is this point, and this point. That is how I can simply solve it in O of n squared time. Cool. Let's quickly see the code. It's pretty simple, exactly same as what we saw also above. Firstly, as you remembered, we have to sort my points vector. Again, sorting on the basis of their x coordinate by default, in the increasing order of the x coordinate. As you can see, when you're, again, I just put it as a c and t. This is a lambda function. This is a lambda function in which you will pass a custom comparator, and this is how you write a custom comparator. This is the two things which needs to be compared with each other. Let's name the vector as c and t, and I make sure that okay, I'll sort on the basis of their increasing out of their height. So for sure, whosoever is less, having a less x coordinate will come first. But what about the same x coordinate? If it is same, then whosoever has a higher y coordinate will come first. This will make sure that. Okay, when you have done a custom comparator sorting, now comes the point that you will go on and try for all the possible c values. So again, the same, I'll go and try for all the possible i's, which represents all the possible cx cy pairs. For every, I'll go on forward, because I know that my t forward is having, okay, more y coordinates. So okay, by default I initialize my k to minus infinity, and then I tried my all again. See, it is I plus 1. Earlier it was not I plus 1, because earlier my entire points were not sorted, but now my points are in the sorted order. Now I know for sure all the points after me will have more s coordinates than me. So I'll just try for I plus 1, and then I will just have a quick check that firstly, if your ty, which means the point of t, if it is more than your point of c, as you saw in this case, as you saw in this specific case, that where is this point gone? No worries. As you saw in this case, your ty was more than your cy, right? So if this is the case, then simply continue. It is not possible to make this point. Else, if it is not, then your k was a benchmark point. If your ty current point is more than the benchmark point, you have found a good pair of cxcy and txty, then increase the answer because you have found a good pair. And then also update your benchmark. Your new benchmark is nothing but a ty, which is a higher value. Okay, you will simply try to maximize your k, which is the benchmark height, and that's how you can simply get your answer in simply O of n square time. And that's how you can simply solve it in O of n square. Okay, time is O of n square. And again, space, as you can see, you are not using any extra space apart from this sorting, and the sorting by default for C++, and Java will take log n time, while for Python it takes n space, and like time is O of n log n for both of the languages, for all the languages, but space in C++ and Java is log n, while in Python it is O of n. So this will actually encounter or take your space, and rest other things will not take any other space. Cool. So your space will be nothing but O of log n, or it can be O of n, depending on the language. Cool. Then again, see you, goodbye, take care, bye bye. It was actually a good question, but not that hard as you have been seeing in the last few contests. But yeah, it was actually a bit tricky to actually figure out the sorting and stuff. But yeah, it was good problem of sorting and geometry. Bye bye.